Okay, let's jump right in. Welcome to this deep dive.
Glad to be here.
Today, we're sort of bridging the gap,
Mm-hmm.
between what feels like really abstract math
Yapulus, yeah.
and something very, very real world, packaging waste.
That's right. We're looking at some material that uses integration specifically to estimate just how much packaging waste comes from processing agricultural goods.
Right, like all the wrapping and boxing for, say, grains or fruit as they go through a plant.
Exactly that.
So the mission for us today really is to unpack how integration, that accumulation part of calculus you might be studying.
Right, the flip side of differentiation.
Exactly. How that helps us actually calculate something tangible, something important like environmental impact from waste.
It's about taking it from the textbook page to the factory floor almost.
Putting a real number on it.
And the source material points out something key. Waste isn't just a fixed pile. It often grows depending on how much stuff you process or for how long. And integration is, it's tailor-made for measuring that kind of buildup over time or volume.
Yeah, I can picture that. Like you've got a production line running, maybe olives or something.
That example.
And for every ton that goes through, a certain amount of packaging becomes waste. The rate might be steady per ton,
Could be.
but the total waste depends entirely on how many tons you actually process, right?
Precisely. And that's where the integral comes in. If you can figure out the rate, say, kilograms of plastic wrap per ton of olives.
Okay.
Integration lets you add up all those little bits of waste for all the tons processed, or over the whole month, the plant was running.
So that's the link.
Yeah.
But how do you actually get that rate? That seems like the first hurdle. The sources must talk about that practical side.
Oh, definitely. That's a big part of it. You need data. Actually measuring, maybe weighing the waste bins after each batch.
Or calculating packaging weight for each finished unit.
Yes, things like that. And it might not be simple. Is it always the same amount of waste per ton?
Probably not always.
Maybe it changes if the line speeds up, or if they switch packaging types. So you need a function, even a simple one, to describe that rate. Maybe waste W equals some rate R times the volume V.
Okay, like W is RV.
Integration then sums up that R over the entire V.
So step one, gather the data.
Yeah.
Figure out the rate function, even if it's just an average rate per ton.
Correct. Then step two, integrate that function over your chosen period or volume, like total tons processed in a quarter.
And the definite integral gives you the total waste. Simple case. If it's, say, half a kilo of waste per ton and you process 1,000 tons.
Yep, just multiply.
Yeah.
Half times 1,000 is 500 kilos total waste. The integral confirms that.
But if the rate changes, if it's more complex,
That's where integration really shines. It handles that changing rate perfectly, summing it all up accurately based on whatever function describes it.
and having that final number, that estimate, 500 kilos or whatever it is, that's actually useful, right? It's not just math homework.
Absolutely. Companies need this for reporting environmental impact, maybe for setting recycling goals.
Or even figuring out if they can use less packaging, save money, reduce waste.
It helps understand the true cost, environmentally and economically.
So connecting back, this whole process going from a rate of change to a total accumulated amount,
Yeah.
that's the core idea of integration, isn't it?
It really is. And you see it everywhere, not just waste. Environmental science, manufacturing efficiency, anywhere, things add up over time.
It just shows that calculus isn't only theory. It gives you tools, practical methods to measure things that build up. Like we said, packaging waste today.
Could be carbon emissions tomorrow or total water used or anything that accumulates.
It makes the math feel much more grounded, more relevant. Finding the area under a curve isn't just lines on paper.
It's a way to quantify the real world, a powerful way.
Okay, so that leaves us, and you listening, with something to think about. We've seen how integration can tally up packaging waste from a process.
By summing up a rate over volume or time.
Right. So the question is, where else out there in the world around you could this same mathematical idea be working behind the scenes? What other important things that accumulate might we be measuring using integration?